Long before motors, cranes, mathematics textbooks, or digital drafting tools, the Khmer people conceived a miracle forged only through human intelligence, discipline, belief, and physical endurance. More than 9 centuries ago, in the dense jungles of what is now Cambodia, tens of thousands of workers from every level of society united to give life to the largest religious structure humankind has ever built, Angkor Wat. They had no modern instruments, yet their measurements match laser precision. They had no steel, yet their towers rise stronger than reinforced stone. They had no cement, yet the temple does not crumble. What they possessed instead was a knowledge inherited through unmistakable mastery, craftsmanship refined over generations, and a profound devotion to cosmic order. Angkor Wat was not merely built, it was engineered as a living model of the universe itself. Before the first stone was quarried, the Khmer master architects embarked upon a sacred mathematical task. Angkor Wat would be designed not simply as a building, but as a cosmological diagram, an earthly representation of Mount Meru, the divine mountain said to sit at the center of the universe. The temple's 5 central towers were to symbolize the 5 peaks of Mount Meru. 3 concentric galleries would represent ascending planes of heaven. A vast enclosing moat, nearly 200 meters wide and over 5 kilometers long, encircled the entire sacred compound, symbolizing the cosmic oceans that surrounded creation. Every measurement followed strict spiritual proportional logic known to Khmer architects. Ratios were chosen for symbolic meaning. Walking distances between galleries corresponded to calendrical time cycles. Even the temple's westward orientation, rare among Khmer temples, likely connected Angkor Wat to the setting sun, and perhaps to funerary symbolism relating to ancestral worship and rebirth. No accident governed layout. Everything was intentional. The surveyors and engineers mapped the surrounding terrain using water-level devices, canals of water acting as precision leveling instruments, ensuring perfectly horizontal foundations across kilometers of earth. Had ground unevenness not been corrected to micro-levels, the central towers would have collapsed centuries ago. Already, before a stone was cut, Angkor Wat was emerging as an engineering triumph. Water was the Khmer Empire's greatest resource, and its most dangerous challenge. The soil surrounding Angkor was unstable, shifting through seasonal monsoon flooding and drought. To construct a megastructure weighing millions of tons, the Khmer people needed to master water control before stone construction even began. Engineers excavated the monumental moat not merely for symbolism, but for geological stability. The moat served to equalize groundwater pressure beneath the massive temple foundations. Without it, seasonal swelling of the soil would have cracked the stone galleries and towers. Water-filled channels surrounding the monument controlled erosion and protected the site from ground collapse during monsoon floods. Within the city itself, a colossal hydraulic system of canals, spillways, dams, reservoirs, and drainage basins, some stretching more than 25 kilometers, directed water inward during drought and outward during flooding. This hydraulic grid fed rice terraces that sustained the enormous workforce feeding the temple construction and prevented agricultural exhaustion of the land. Angkor Wat depended upon this water system both for food supply and for survival of the monument itself. The Khmer had effectively designed the world's earliest integrated urban engineering network. The birth of Angkor began 40 kilometers north in the sandstone cliffs of the Kulin Mountains. Here, quarry masters analyzed natural fault lines running through exposed stone faces. Using bronze chisels and adze blades, workers would carve long grooves following these lines. Wooden wedges were hammered into the cuts and soaked with water. As the wood swelled, enormous internal pressure fractured stone slabs from the bedrock. No explosives, no saws, only physics, pressure and precision. The stone sheets detached were further shaped into rectangular blocks weighing between 150 kilograms and 1,500 kilograms each. Hundreds of thousands of such blocks were produced. Each one was inspected by foremen. Cracks or imperfections meant immediate rejection. Quality control was absolute, because mistakes would destabilize the entire temple superstructure. Stonecutters smoothed rough faces on site using river sand abrasives and stone polishing techniques. Blocks were carved broadly to size before transport, saving weight, while decorative refinement waited until the stones reached their placement positions. Each stone was marked by quarry symbols, likely indicating its destination level within the temple galleries. Every piece had a purpose before it ever left the mountain. Transporting millions of tons of stone through jungle terrain represented one of humanity's greatest logistical feats. Khmer engineers rejected wheeled carts, unsuitable for muddy rainforest soil, and employed sledges. The stones were lashed to wooden runners and dragged by manpower teams alongside elephants. Elephants hauled the heaviest blocks, guided carefully by mahouts, trained to navigate narrow jungle passageways. When seasonal rains flooded the plains, Khmer engineers used water transport. Custom-built barges floated tons of stone directly into canal networks, connected straight to Angkor's building site. The canals were carefully dredged to allow deep-draft stone barges. At unloading docks near construction zones, cranes didn't exist, only rope systems where teams rolled stones onto earthen ramps. Incredible coordination ensured constant flow of materials, never allowing the worksite to halt. Once on site, stone layers began construction with deep structural foundations. Trenches were excavated and filled using tightly compacted layers of laterite stone, a naturally hardened, iron-rich soil perfectly suited to distribute extreme weight. Laterite's porous structure allowed water drainage, preventing ground saturation beneath the temple weight load. Above the laterite layers, thick stacks of sandstone created load platforms supporting gallery corridors and towers. Unlike Western foundations set into deep underground footings, Khmer foundations rested on engineered pressure dispersal systems, spreading weight laterally across wide stone beds. This is the very reason Angkor Wat's towering structures do not sink into soil even after 9 centuries. No cement or binding agent was used anywhere in Angkor Wat. Instead, Khmer builders carved stone blocks with precise interlocking joints and gravity lock bevels. Edges were angled so blocks wedged together when stacked. Hidden stone dowels pegged large slabs together within galleries. Weight alone ensured cohesion. This system allowed micro-movement during thermal expansion without fracturing the structure. An engineering solution modern architects still study today. Scaffolding was built entirely of bamboo and hardwood poles bound with rattan lashings. Bamboo ramps sloped upward along each rising tower, dismantled and rebuilt continually as stone levels increased. Rope and pulley systems lifted blocks, guided by coordinated lifting chants to synchronize workers' strength. Some stones were hoisted to heights exceeding 40 meters, using little more than rope teams. Without error tolerance, all lifting operations were meticulously planned. Riggers calculated rope tension based on stone weight, knowledge developed empirically. Injury and fatalities were accepted risks, yet work did not stop. Layer by layer, gallery walls rose. Column by column supported vaulted stone ceilings designed to distribute downward pressure outward, preventing roof collapse. Center towers emerged from densely stacked stone cores, heavier than solid pyramids. Angkor's structure is not hollow. It is mountain-like in mass. After stone placement, carving teams arrived. Instead of carving beforehand, risking damage during transport, artisans sculpted directly into assembled walls. Design masters sketched chalk layout grids onto sandstone. Teams then chiseled relief scenes hero by hero, dancer by dancer. Over 12 kilometers of carvings constructed monumental narrative friezes. 2,000 Apsara dancers were carved with fully individualized faces, no duplicates. Sculptors mastered anatomy proportions centuries before Renaissance anatomical studies. Faces convey divine serenity, subtle smiles, and individualized features. Each bas-relief could take months to complete. Carvers used hardened bronze blades and sandstone polishers. Pigments were applied, reds, blacks, gold leaf, now lost to time. Angkor Wat was built by entire communities, not slave labor. Workers lived near construction, supplied by state-supported rice farms. Rotational labor shifts were used. Villagers worked months at Angkor, then returned to farming cycles. Women prepared food, dyed carving pigments, traded supplies, and served as dancers and ritual caretakers. Children were trained as apprentices, learning carving, rigging, or surveying skills. The work was spiritual, not simply labor. Construction itself was an offering to the gods. Angkor Wat required approximately 30 years of continuous labor from initial earthworks to dedication. Fathers trained sons to carry on unfinished masonry. Entire towers were raised slowly, sometimes only adding a few vertical meters per year. Seasonal flooding slowed work, yet never halted it. Upon completion, Angkor Wat dazzled. Golden statues of Vishnu filled inner sanctuaries. Painted galleries glowed. Prayer smoke drifted above reflecting moats. The temple became a living ceremonial complex, housing worship, festivals, dance rituals, and royal processions. Angkor Wat remains the ultimate proof of what united human brilliance can achieve without modern technology. No shortcuts, no machinery, no cement, only knowledge, applied to stone. From cosmic design to hydraulic engineering to stone cutting, transport, carving, and gravity-driven construction, Angkor Wat remains not merely a monument, but a civilization frozen in stone, a human masterpiece